Page 1, going to show you which materials to use for names and formulas. I'm going to be using my periodic table, both sides, and also the piece of paper that says name to formula. It's got a lot of questions, and it says, do you see the word acid? In this section, in this case, you aren't going to have any on this front page, so we're going to keep the acids away from it. So the biggest thing will be deciding whether it is a ionic or molecular and naming it accordingly. First one says copper 2 sulfate. Is it an acid? No. Do you see any prefixes? No. Although I see a Roman numeral. So that's going to tell me that I have to, it's an ionic compound, I have to think charges, plus or minus, and crisscross. So I look up copper. Now, copper doesn't have a charge shown because it's transition metal. That Roman numeral tells you that it's Cu with a +2 sign. Sulfate, find that on the back. Sulfate is SO4 with a -2 charge. SO4 with a -2. Match made in heaven, CuSO4. Next one, also not an acid, also no prefixes, it's ionic, iron 3 chloride. Iron is also a transition metal. You're not going to find its charge at the top, but it tells you it's an iron with a +3 charge. Chlorine is on the nonmetallide side. It's got a -1 charge. Chlorine with a -1. This is not a match made in heaven. If we have a +3 but a -1, it's going to take 3 -1s to balance off just 1 +3. Net charge of a +3 over here, net charge of a -3 over here. FeCl3. Next one is also not an acid, also no prefixes. Find aluminum. Aluminum is in a predictable column, +3. Oxide is on the nonmetal-ide side. Oxygen, -2. Once again, if we were following these down and once we saw that it's an ionic, we have to think charges and we have to crisscross on the wrong side. 3 of those, 2 of those. Al2O3, aluminum oxide. Potassium phosphate. It's a metal to a nonmetal. Potassiums have a +1 charge. Potassium +1. Phosphate. You can look all on the front, but finding its last name, does the last name end with ide or ate or ite? Ates or ites are on the back of the periodic table. They are polyatomics is what they're called. So I got to find phosphate on the back side. Phosphate, phosphate, there it is. Phosphate, PO4 with a -3 charge. PO4 -3. Not a match made in heaven. It's going to take 3 of the +1s to balance off just 1 of the PO4s. It would be written as K3PO4. The next ones, you have to put a name given a formula. Piece of paper, also going to use, I'm still going to use my periodic table, but this time I'm also going to use the formula to name. None of these are going to start with H. None of these are acids on this side, but so I'm going to ignore the side over here. None of them are acids. So does the formula start with thing? The next thing we have to determine is whether it's the first element is a metal or NH4 or not, because that will tell if it's molecular or ionic. First one we're dealing with, Fe. What is Fe? You find it up here. There it is. It's a metal. Since it's a metal, the next thing that we're going to look at is, since it's a metal, it's an ionic compound. So the next thing we have to ask ourselves is, so we're going to name the positive ion first. It's called iron, but does it require a Roman numeral or charge? How do I know? Well, if it's not in a column, here's iron, and it's not in one of the columns like this one, or this one, or this one, which tells me the charge, then it needs a Roman numeral because there's multiple ways that it could be charged. This tells us, so this is iron, but we're going to have to figure out what Roman numeral it is. Its last name is NO3. That's a polyatomic. We'll find it over there. NO3, that's nitrate. So its last name is nitrate. What we need to do is determine, backtrack a little of what is the charge of this iron, so I know what to put in the parentheses. I'm going to do a little reverse in it here. If I take Fe, NO3, taken twice, I know it comes from the Fe plus something, and it comes from the NO3 with a -1 charge. It's like reverse crisscrossing. This, we only had one iron, but we had to have two of these. It's going to take two, the iron has to be a +2 to balance out two -1s. So it's iron 2 nitrate. Next one, is it a start with H? No. Does it start with a non-metal or a metal? Ca is a metal. It's called calcium. So its last name simply is just so it's not a molecular in this case, it's an ionic. Its last name ends with "-ide", that means it's monatomic. We find it on the non-metal "-ide" side. So where would I find? I would look at this and say, okay, I got to go find this Cl. Well, that's chlorine. It's going to be chloride. Metal, its name is chromium. Chromium is here, so it requires a Roman numeral because nothing tells us. I'll put that into parentheses. OH is always hydroxide. OH is hydroxide. When I go find hydroxide, here it is. It's OH with a -1 charge. Since I have two of those, two -1s for a grand total of -2, it must be the chromium plus something. It's got to be balanced out by a +2. It must be a chromium 2. This kind of tells me that it's chromium 2 because that's a -1 charge. Next one. Does it start with H? No. Does it start with a metal or a non-metal? This S is a non-metal. So let me go look at my little things where I'm trying to get from formula to name. Formula to name. Is the first element a metal? No. It's a molecular compound. The first name of the element as is. We are going to just leave it as is. And since it's a non-metal and its name is sulfur, we're simply going to call it sulfur. Check the rules to find out what about the last name. The last name, whatever that element is, it changed so that it ends with "-ide". So I'm going to take what I'd find as Cl as chlorine would become chloride. I left a little room there. There was another note on these little things that says you have to use prefixes to tell how many. Use prefixes. Mono, but we don't need that if there's only one of the first one. And 8 is octa, so I'm looking for the 8 sulfur octa chloride. You might be tempted to put a monosulfur, and it technically tells people what you mean, but the mono is not needed if it's the first one. Next one, NO5. Start with H? No. Start with a metal? No. Once again, it's a molecular compound. Down here, molecular compounds are non-metal to non-metal. You use molecular prefixes to name them. So I'm going through these same sets of rules that we just went through over here. First name, as is. That would be nitrogen. There's only one of them, which would be sort of meaning mono, but we don't put it for the first. Mono isn't necessary for the first one. Next thing is make it end with "ide," so it's oxide instead of oxygen. And there's 5 of them. I can't remember what the prefix is. There it is. Penta, 5. Nitrogen, pentaoxide, or simply pentoxide. Here's a familiar one. It's a metal tied to a nonmetal. Sodium chloride. No prefixes necessary since it's ionic. There's only one way it can go together based on its charges. SN. Find it. Here's a trickier one because it's in this column that says it's a -4, yet it's this metal, and metals always have positive. These columns are nice. It's nice to have some stuff up here, but there's some exceptions, and it doesn't always hold true. Tin is a metal. It's a metal that needs a Roman numeral. Tin something, F. F is a nonmetal. Fluorine, so it becomes fluoride. So how do we figure out SN, F4? F always has a -1, so we have 4 -1s. That must have been tin question mark. If I reverse crisscross, I'll find out it must have been tin 4. Is that I? I'm just going over here. Is it I? Oh, it's IV. V. That's the Roman numerals. It'll be tin 4 fluoride. Tin, IV, fluoride. Finally, this last one, NH4. Can be tempted to be, it's tricky because it almost looks like it's a metal, but then it's tied to a nonmetal and another nonmetal. So there's something tricky about this. What we really have is an ionic one, sort of a tricky one. Like if we went back to this one that says, is the first element a metal or NH4? Yes, this one's first name is NH4. Yes, it's ionic. It is the one thing back here that has a positive charge. NH4 is ammonium, not ammonia, ammonium. So its first name will be ammonium. Its last name is based on that OH hydroxide.